welcome back to Lounge with Larz. Today's guest is an engineer who doesn't just work with ideas, he brings the impossible to life. He's led teams tackling everything from supersonic machines to space launch and reentry. And now he's pushing the limits with AI and high performance computing. At the heart of it all, he's driven by curiosity and a passion for invention. I'm excited to welcome Allan Grosvenor to the show. How you doing, Allan?
Good, Ryan. Thanks for the invite.
Yeah, no worries, man. Little hiccups dealing with the internet, but we're managing through it. But how you doing? How's your day going? And
back in Los Angeles now. I'm doing good. Thank you. It's been an interesting summer. Lots of travel, just in the country mostly, but I'm back in LA right now.
That's fabulous. What part of LA are you at?
I have been in the process of moving to the west side of LA. I was in San Fernando Valley for a while.
Very cool. We were just out there for the summer. I shouldn't say not in LA, but Laguna out in California. And we stayed at a awesome little hotel out there, had a 4th of July with the kids. It was amazing. I don't want to be in Arizona, that's where I've lived most of my life. And don't want to be in Arizona during July for sure.
I've spent some time in Maricopa County during that time of the year. I know what you're talking about.
Oh my gosh, hot as the dickens out here. So have you visited? I think we talked a little bit about you visiting maybe 1 or 2 times.
I, in fact, briefly lived in Arizona a long time ago.
That's right. Very cool. And you lived in Scottsdale, I thought.
Yeah, I was in Scottsdale for a while and I enjoyed it. I love the desert, but I didn't love the highway driving so much.
Yeah, and it's gotten worse, Allan. It's definitely crazy out here. I think I bought my first house in Gilbert when I was about 20. And fast forward, I'm 48 right now, but I just bought another house in Gilbert and it's completely changed. Obviously, it's been built out like just crazy. But yeah, what used to be the suburbs is now just the hub of everything. They have a Lifetime Fitness going up just north of us, which I'm super excited about. I love working out. And from what I saw, you love working out because it keeps you sane.
Yes, good for both physical health and mental health.
So what do you like to do as far as working out? Do you like weight training or just cardio? What's your focus?
Yeah, I like intense weight training. I also do some heated spin classes that are pretty intense and have some outdoor sports I enjoy too.
You know what? That's interesting that you just mentioned that because there's a place that I go to that has like a sauna with a cycle bike and you could crank that sauna up to 130 and just hit that bike. And in 15 minutes, you are just pouring sweat. It's a heck of an exercise. Is that something similar?
Yeah. In this case, you have an instructor and you have a room of students on bikes and they have heaters in the room to heat it up. But yeah, that's the idea. It's good in terms of intensity for sure. Also, it's good for your joints.
Yeah, I was dealing with a little bit of a wrist injury and someone mentioned this to me and I went in there and yeah, it started definitely loosening up. So I was tickled pink when I found out about it and it started working. I was like, wow, it's definitely a no-brainer to continue to do this because it's good for just sweating out all those impurities that we all have right now and stresses.
Absolutely.
So tell the listeners a little bit about yourself, your story, and what you're into now.
Absolutely. When I was a child, I didn't pay attention so much in school always, but I always loved science fiction. And that was something that always fascinated me. And I found different ways to attempt to make stuff from some of my favorite science fiction. And thankfully, because of my mother and some other really great mentors in my life, I discovered that you can actually have a job making science fiction a real thing. And that's what I've been doing ever since.
That's awesome. You got to love the moms and the dads who just support what you're doing in life, right? It's so important. So as a kid growing up, what was your hobbies? What did you like to do? And moving into adulthood, did you keep those like kid dreams alive? It sounds like you did.
Yeah. The making science fiction real has been the one that lasted the longest. Other than that, when I was a little kid, I used to skateboard a lot and I do lots of board sports now. And I think that in general, I was very curious when I was a kid and I've tried to maintain that curiosity. And it's so important to have that kind of mindset. A lot of people, it's just very easy to, over time, develop a fixed mindset, believing that the way things are now are pretty much the way things must be, and nothing can ever get better. And of course, things can get way better. And part of making things better is being curious and thinking about possibilities, and also being open to opportunity, and just trying to maintain a mindset that makes success at least possible, if not inevitable. The more you can convince yourself that, yep, I'm going to do this, and it's going to be a big change from the situation I'm in right now, and it's going to be worth it. So I think curious mindset is another thing that I've maintained since childhood that's served me.
I love it. I love it. Yeah. Mindset is definitely one thing that you can't shy away from, right? If you have a determined mindset, it's just going to be that's going to be your focus. And making those dreams come true, you're going to have a dedicated mindset. And it sounds like from when you were a kid up to now, that mindset hasn't changed. You've almost tried to turn the impossible to the possible, which is, I love hearing these types of stories. So you were a skateboarder, huh? I'm going to lean into a little bit of the stuff that I think the listeners are going to want to know a little bit more about Allan. So how good a skateboarder were you?
This was when I was a child. So I was fine. I had other friends that were way better, and some that could have been professional. Like they weren't, but they could have been.
Like Tony Hawk style.
Yeah.
Wow. Okay. Very cool. On my 8th birthday, my parents bought me a skateboard, and they made me a little cake, and they said, "Great skate, Ryan's 8." And that was so cool when I saw that cake, and then they brought out a skateboard. I was like, oh man, I just used to skateboard all the time. I love that we connect on that front too, for sure. So
Sounds
now,
like a lovely memory.
yes, 100%. There's so many good child memories that I'm sure you have and that we all have, but skateboarding and riding my bike, it sounds cheesy, but those are the best memories that I had as a kid.
Carefree times.
For sure. Fast forwarding, now you're coming out of high school, you're moving into college. What did you focus into like your college years? What was that focus look like?
Yeah, I decided that I wanted to become an engineer and that I wanted to focus on aerospace. I started off by doing a mechanical engineering undergrad degree. Then I did a master's in aerospace. And so I grew up in Canada. In Ontario is the province, and I was born in Toronto, and then I moved to Ottawa for school. So this is toward the eastern portion of Canada. It's like above New York. Toronto's kind of above Detroit, and Ottawa's more like above New York. And it's close to the border with the province of Quebec, where Montreal is. In Canada, there wasn't a lot of aerospace happening. There was a tiny little bit at two very large corporations, but compared to what's going down in Southern California, for example, there was really no comparison. And I wanted to work on supersonic jets and rockets to fly to space. And there was nothing like that at all happening in Canada. I was in school in undergrad. I searched for different ways to find out how I could actually get into this when there was none of it around me. And we had at the university, a engineering society for students. And I got involved with that. And over the years, ended up leading it for a while. And it was a great opportunity because I would set up student field trips to different companies in the general vicinity, and got to meet a lot of interesting people at these companies and see a lot of very interesting facilities where they're doing different types of engineering. And as I was talking to more and more of these different types of people, I got more and more ideas of how I need to go about getting into this kind of career. But also, one day I was reading an industry space magazine that would come out, and they were advertising this conference that was happening in Florida that summer. And everything that they listed happening at this conference, it was called the AIA Joint Propulsion Conference. AIA stands for American Institute of Aeronautics and Astronautics. It's a society for professionals in aerospace engineering. And so they had this conference, and when I looked at the proceedings for the conference, everything looked like, wow, this is exactly what I want to be doing. And so I just decided I better get there, and ended up finding my way there on a extraordinarily slim student budget. By the time I arrived there, I didn't have any more money left for food. So I was just
Oh,
attending lots of sessions at the conference that had,
guys you got to get your fill some way.
but it was fine. And it was a huge eye opener for me. There was a lot of things that I started discovering on site at that event that I went to that ended up being pretty formative for the rest of what I ended up doing. One of the things that I already had an idea about, but something that really brought it home for me was at this conference, people were presenting new technologies that they were working on developing that would be practically impossible for them to develop and explore and advance if they were not using computer modeling and simulation. And just to give you a basic idea of what I mean by that, if, for example, you want to design an aircraft that flies 5 or 6 times the speed of sound, that's an extraordinarily expensive endeavor. And there are many different ways that can go very wrong. And in the old days, you'll see movies like The Right Stuff, and there are lots of movies about test pilots in the old days. And test pilots deserve ultimate respect because, and I like that's true now today, absolutely was true a few decades and more ago when they didn't have the kinds of supercomputers that we have access to now that enable people today to run lots of high fidelity simulations and really explore how this thing is going to fly like we've never been able to before. In the old days, you had mathematicians and engineers who had extraordinary understanding of the physics, very economical equations that they were able to solve with a slide rule, with a calculator, with a rudimentary computer of the type that they had at the time. In the United States and in other countries too, there are aviation wonders that have been achieved with extraordinarily little compute power. But also, if you look at the kinds of designs of an aircraft or a rocket, they fall into just a small number of categories. And within those categories, they didn't change that much between the 50s and the 90s or even the 2000s. And for example, if you look at photographs of a transatlantic airliner starting in the 1950s and then look at one at each incremental successive decade, between the 50s and the year 2000, they look quite similar. They don't look fundamentally different. Now, more and more these days, a variety of different types of flight vehicles, for example, have started to depart and have some different kinds of features that you have not seen before. And the reason why is because in the old days, you would use your elegant calculation techniques. You would be drafting on vellum. You'd be going to the machine shop and you'd be fabricating prototypes, subscale ones to test in a wind tunnel, and then either half scale or full scale as some kind of flying prototype. And you would not do a huge amount of exploration of the flying properties of this new vehicle until you had a full scale prototype that test pilots strap into and fly around. And that's why they deserve so much damn respect, because these were professionals that were such incredible pilots that they could get into a brand new vehicle and not just fly it in standard conditions, standard takeoff, standard climb, standard cruise and descent, etc. But they could also put it into maneuvers and during the maneuvers experience unexpected aerodynamic behaviors and still be able to write it again. Now, it's beyond amazing what some of these people have pulled off. Also, there have been a lot of catastrophic, horrible accidents.
Sure, yeah.
Where the pilots would get into situations that they were not able to escape from and perish. These days, we are able to build really sophisticated computer models of these kinds of designs and run a broad range of really high fidelity, high quality simulations. And we can run a lot of them so that we can explore the entire flight envelope of a given flight vehicle and also explore in detail the stability and the controllability of that vehicle as well. And so now it's a lot more feasible, and we're able to achieve an adequate prediction accuracy of those physics with those simulations. And so as a consequence, it's possible now for us to explore designs that we just couldn't before. And I started realizing that when I went to this first conference. I started realizing, wow, it seems like modeling, simulation, computational physics is enabling new inventions in aerospace. And I decided I better get into that. And thankfully I did. I was extraordinarily fortunate that a professor at my university was a deep specialist in fluid mechanics, aerodynamics, and also computational aerothermodynamics. And that ultimately turned out to be extraordinarily fortunate for me. A lot of students were afraid of this professor because his courses were hard. And as a graduate school advisor, he had very high expectations. That was great for me because I had really big goals. I was not there to do some kind of mediocre thing and skate by. I was there to transform my life and reach out and try to achieve my dreams. And I knew that was going to be tough and that I would need to push myself and I would need to be pushed. Other students did me a favor and made that guy a lot freer than he might otherwise have been to take students like me. And I was extraordinarily lucky to, during undergrad, do a directed study with him, which is really the first formal way that I started getting into aerodynamics and computational fluid dynamics. He ended up selecting me to do a master's later as well and continued that work. And that's how I first started getting into that stuff. By the time I was graduating, I was very fortunate to take one position for a while with a company that actually was developing that kind of software. I've worked at some research and development companies in energy and also in space launch before I finally started my own company.
Gosh, that's amazing. Some of the big things that I've heard, obviously having a great mentor. Sounds like you had that professor who just took you to levels probably that you weren't aware of. I think that is just so important in the life we live today, is having that mentorship. Gosh, while you were talking, I was thinking of the new Top Gun with Tom Cruise and the test pilot. And at that, right at the beginning, he's flying like supersonic. And I'm thinking of all this. Yeah, hypersonic, exactly. And then he ejects. And I'm like, I couldn't even imagine what these test pilots have been through and what they're still going through, obviously thanks to everything that you're doing in that field. But some of the things that you mentioned was just, a lot of people don't understand how important the things that they don't know, when you start applying it and sharing that knowledge, it's your eyes light up, your imagination starts to unfold. And that's what was happening when you were talking. I'm thinking of these cool old school test pilots and all these calculations of like, what if they're banking this direction, and if their algorithms are off or wind direction is off, what could happen? And I'm thinking of different movies, and it was literally, you were drawing me in. So I think it's so cool that having an opportunity to see that firsthand. Not a lot of people get to do that, Allan. I think it's important for you to share that. And most kids, they don't know the direction, how to get into this. So for you explaining that and having a mentorship through your professor, that's what I think we all need, is just someone who's going to guide us into an area of our life that's going to just make us explode, just make us more knowledgeable than we ever thought was possible, which is so cool.
Yeah, absolutely. And life is precious and extraordinarily short, and might as well spend the little time that we have going after something that's exciting to us, also loving each other.
That's important. I'll tell you what, as I continue to go through life, I think having a tight community and finding people that you're connected with is so important. And is that the same with you? Like in your stage of life, you try to connect with like-minded individuals and just share those life journeys with different people?
Yeah, I'm very fortunate to have some really great people in my life that we definitely share a lot. And it's funny that you say, because I don't have identical thinking process with anybody, and I know that's not what you mean, but I also have some friends and colleagues that I'm of a very different mind about some things with, but I like that. Nobody knows everything, and nobody has an equal number of types of experiences and perspectives as a consequence. For me, certainly in the past, earlier in my life, before I really thought about this, I would sometimes be annoyed if someone has a particular opinion. Name your favorite top 3 hot button issues that'll get everybody angry, and choose one of those.
Right.
But what I realized more and more is that where you grew up, how you were raised, the community that you're from, all your life experiences form these kinds of attitudes and expectations and what's normal and what's not. And some people grow over time a lot. I love having the opportunity to learn and think about things differently. And I also enjoy having friendly debates. So I have some really great people in my life who I disagree on some issues, but we care about each other and respect each other enough that we're not going to make it personal. We enjoy just debating. And also, it's enjoyable when someone has a very different opinion about something and you're able to have some kind of friendly, respectful debate. Then it stretches you to think about it and really test how much reason you actually have for thinking this point is a certain way. And so it causes you to grow. It also causes you to imagine why they have that perspective as well, which makes you closer no matter where you're from and what political stripe, etc. you might have. We all have very common interests. No matter who you are, you want to breathe clean air, I think, and you want to drink water that's clean, and you care about what's going to happen to young children. You want them to be safe and have education and health, etc. And so I think even if you have very strong different opinions on some things, a lot of us can share common ground and work together and achieve some beautiful things if we realize that.
Yeah, common interest for sure. That's what unites us all, right? It's just that common bond. Yeah, we need clean air, good water, and we just need a good community that we can share our ideas and our thoughts. And then obviously, I want to allow people in my life that don't have my same mindset or don't have my same thinking, which allows me to grow in my own personal way of, okay, this is how they're thinking, and just try to identify. And I think that's where I'm at in my life right now is like, I really to just sit back and listen, and I feel like I'm growing more when I'm listening to others. And yeah, there's a lot of people who get upset if you say the wrong things, or if you're
That's exhausting.
It is. It's exhausting. And I'm 48. I'm already exhausted enough with 2 kids. I just want to be understanding and compassionate to my fellow man. And yeah, I think that's cool. That's the approach that you're taking right now in life. Yeah, I can't say enough about that, which you just mentioned. So thank you for sharing that for sure. So you're doing some crazy things right now. Like I just saw, so tell us about your business right now.
Absolutely. So in fact, I have 3 companies now. My first business is called Ms.Bay, and that's what we do there is build and train artificial intelligence for digital engineering. When I say digital engineering, that means this modeling and simulation for a very broad range of purposes, any kind of product design you need it. Also, any kind of operational characterization of anything from an aircraft to a car to a nuclear reactor. You got to design it. And once you've designed it and really perfected the design as much as you can and made sure that it's manufacturable and affordable too, then you need to then characterize the operational behaviors so that you can build systems to enable it to have robust, fault-tolerant operations, et cetera. That's digital engineering. And then the other aspect of that business is operations. And 2 quick examples: space operations in space domain awareness and space traffic management. You have an exponentially growing number of satellites going into space lately, and there's not enough personnel that are trained to manually monitor all of them and make sure that they're all like stable and not colliding, avoiding emergencies, etc.
So they need their own lanes up there?
Ideally, you don't want one of these vehicles intersecting the path of another one if they're going to be coincident. That's a beautiful application for the kind of autonomy that we build. Another kind of example is industrial facilities. That actually pretty much the same technology that we originally built for space operations, we also have adapted and extended to run industrial facility operations. For example, in reactor, newer small modular nuclear reactors and microreactors, more and more, they want to be able to operate these things for long durations of time in sometimes remote environments. And it's a beautiful example of where a well-done autonomous system can increase your safety and improve the operational performance and reliability. In both of those examples, essentially, you take everything that we do for digital engineering, which is training artificial intelligence in such a way that is able to perform a series of learned events and pose them into a new plan to carry out an entire workflow for somebody. So I'll give you a couple of quick examples. One kind of event would be a navigation event. You need to navigate a file system. You need to find files and to write files. You need to navigate a database to find data from a particular database. If you're driving some graphical user interface of a software package, you need to navigate using computer vision. Navigation events are just one class of event where particular artificial intelligence technologies are a better fit for that. And what you use for navigation events are very different than large language models that people tend to think of these days when they hear artificial intelligence. We, for example, use graph neural networks as part of that process. You have discrete actions and associated decisions, and there's a series of methodologies and tooling and infrastructure that we've built to train for those kinds of events. Ultimately, you want those composed all together into a brand new plan, and we do a lot of reinforcement learning and some other methodologies to accomplish that. Well, if you're able to take that kind of what we call a hierarchical system to perform an entire plan like this, and you're able to measure the reliability of all of these events and actually verify and validate their reliability. If you're able to also do complex time series problems, detection of anomalies in time series behavior, and you're able to also do prediction, then you can do really effective operations. In space operations, for example, you have to do all the navigation and discrete actions and entire plan in order to enable a user to say, okay, here's the NORAD ID of this particular satellite I want you to focus on. Now tell me in the last series of orbits if it's done anything anomalous or if it's doing something normal. If you are detecting it's doing something anomalous, tell me what that is. If it's a maneuver, tell me what the maneuver type is and why it likely is doing that based on its past orbits and what it might have done in some of those. So that's an example of something that we developed and delivered to Space Systems Command. And that same kind of system is what we have repurposed and extended to industrial facility operations. We're starting to do this for nuclear reactors also, where in that case, of course, if you have a microreactor that needs to operate robustly for long durations of time without any kind of human attention, and you want to make sure you are achieving maximum safety, maximum reliability, then you want to be constantly assessing the behaviors of all of the equipment in that reactor and all the behavior of the entire system to detect anything that might be anomalous in terms of nothing that's emergent as something that you need to be immediately worried about, but a long-term kind of variation that indicates the possibility of the future need for maintenance or the future need for something to be updated so that you can ping like a signal up to a satellite and bounce it back to human operators wherever they might be to let them know there might be this type of servicing that's needed, or you might want to command a reset of the system maybe, etc. And it gives you a snapshot of what we do at my company, Ms.Bay. And then, very long story short, I have two other companies that I've co-founded with some other really amazing people. One is called Nexcavate. And at Nexcavate, we're applying that technology to speeding up land use permitting with a particular focus on mining. And there's some recent executive orders that call for new solutions to reduce foreign dependence for critical minerals. One thing that we can do is we can realize that in the United States, it can take 29 years to go from exploration to a productive mine. And a large percentage of that time can just be the permitting process. The permitting process is ripe for disruption, and that's what we're doing in Nexcavate, and it's extraordinarily exciting right now. Actually, we've been working on. We're very fortunate that we have a pilot customer and user in Nevada with the state of Nevada that gave us some really powerful use cases. And we had some really important interactions with them as we were demonstrating the first version of a system that we built that we call Permit Pulse to automate the process. Good at mining. Maybe not so good at building mining plans and writing permit applications. So we can give them some help. And so that's very exciting. And it's a really key time to be working on that. I have another company that I've co-founded, and my co-founder, his name is Prince Stash Rolla. And if you look him up, he's a fascinating guy. There are articles in The Guardian and elsewhere that you can read about his incredible life. He is a true renaissance. There are stories that you can read about him and the days that he was hanging out and getting into trouble with the likes of Paul McCartney and Mick Jagger. But these days, he had an inspiration to revolutionize nuclear energy. Talk about a renaissance man, right?
Yeah, that's crazy.
And so we got to talking as a consequence of a community that we both belong to that's called Metal. And it turned out that I totally saw his vision. I thought it was a good time for it. And also I happened to have some technical experience that was a good fit. And so we started a company together that's called Tamfordis Solutions that is focused on beyond state-of-the-art small modular nuclear reactors, particularly micro reactors. And what we're particularly focused on are ones that are small, compact enough that they can be portable or mobile. That's a really exciting project. It's a obviously very serious hardware project, but it's, again, a beautiful application for state-of-the-art AI for autonomy, because actually the microreactors that we're focused on are for explicit remote operations kinds of purposes. I'll give you two examples. One is a Department of Defense use case, forward operating base. These are bases that they're erecting quickly. And of course, if you can fly in on a helicopter, plug and play power, that's way better than what they often do, truck in huge volumes of kerosene and burn the kerosene in generators, and then next week or next month have another convoy of trucks with more kerosene, which if you're in a territory where you're not entirely safe, then you're leaving yourself a little bit too open. If you're teaching people around you that every so many days or weeks from now, there's going to be another convoy they can expect. And so it's a game changer for DoD. And also turns out that it's a really good thing for disaster response. Again, if you have an earthquake, a flood, all the power's out. The first thing that the emergency first responders that show up there need is power. And so again, if you can helicopter in, plug and play power, it can be a game changer.
That's amazing. So 3 companies, you got to be a busy man.
Yeah, but I could be busy doing a lot of things, and these things are exciting and keep me getting out of bed in the morning.
It sounds like it. What's next for Allan and the business? What are you looking to accomplish in the next maybe 3 to 5 years?
Yeah. What we've accomplished so far is we've done a lot of proof of concept, a lot of prototyping and delivery of first products. But now we're in our growth phase. We've demonstrated enough and we've achieved maturity in some of these products that we're able to start scaling them up. So far, we've been doing a lot of contract and licensing engagements, mostly with government, although more and more now also with commercial customers too. But we're moving into a phase where it's going to be possible for the AI-driven products for us to be able to sell licenses of those. And we are working on launching the next generation of our Guru system that we use for both the digital engineering and the operations use cases. And we're building Guru Generation 2 right now for both some government customers as well as for the purpose of commercial release. And that will run on commercial cloud. And that's one thing that we're working on scaling right now is we're working on accelerating that effort, making sure that we're seizing all the opportunity in front of us for that. And everything that we're doing is extraordinarily similar to the way we're growing in the other two companies, Nexcavate and Tamfordis, with those products as well. We've graduated from pretty long duration of time where we were doing a lot of research and development to figure out how to actually get this stuff to work. And we figured out a lot of things now, and we've learned a lot of hard lessons, and now we're starting to scale. So we expect that we're going to be able to like 10 to 100x our annual revenues over the next 3 years. And so in fact, we're doing some new fundraising to make sure that we move fast and go and get it.
Amazing. If people are obviously interested in maybe deploying some capital or just interested in this space, where can they go to reach out to you and just explore a little bit more about what you guys are doing and some of the offers?
Absolutely. So in general, my first company is Ms.Bay, MSBAI, and the other two companies are Nexcavate, Nexcavate, and the third one is Tamfordis Solutions, Tamfortis Solutions. Thankfully, each one of those company names is unique enough that if you just throw it in Google, you'll probably find us. But also you can email me directly. My email is at MSBAI. It's literally Allan, Allan, Allan at msb.ai. And at Nexcavate, it's literally Allan at nexcavate.com. And at Tamfordis, it's Allan at tamfordis.com. Also, we have Instagram, we have LinkedIn, we have Twitter. So you can find us on those and DM us there too.
So cool. Yeah, I'll definitely put some of the links where they can find you through social and some of the websites. But man, Allan, you got an amazing story. Like, I truly applaud everything that you're doing. You're a true trailblazer, and we need more guys like you for sure. So I appreciate you hopping on here, sharing your story. And man, it's been an incredible time with me. I appreciate you.
It was a great conversation, Ryan. Thanks.
Yeah, no worries. Thanks again.
Take care.